Hi guys, we're back and we're still on the same lesson that we were doing yesterday. We're graphing rational functions. Just to remind you of the steps, we're going to find the domain of our function. We want to factor and simplify it, write it in lowest terms or simplest form. That's all lowest term means. Then we're going to find the x and y intercepts. We find the vertical asymptotes and holes, find the horizontal or slant asymptote. We determine if it crosses. Don't forget this step. I sometimes forget it. Pick a number from each interval and determine the sign. We did this 2 different ways yesterday. We'll probably do it 2 different ways again today. Remember, I'm not getting that critical because you're going to put all of the important information on by hand, and then you're going to check it in your calculator. So those points, the testing, not so important. Okay, so I'm going to go to the graphs we're going to do today. We want to look at this function first. R of x equals 3x squared minus 3x over x squared plus x minus 12. We start by identifying the domain. So we're going to set the denominator equal to 0. So these are our restricted values. So our domain is x can't equal -4 and x can't equal 3. Another way we could write this, don't forget, is -infinity to -4, -4 to 3, and 3 to infinity. And this way you kind of see the breaks in the graph. The second step, we're going to factor and simplify. So I have 3x, x minus 1, x plus 4, x minus 3. And since nothing cancels, it is in simplest form. My x and y intercepts. I set the numerator, the simplest form of the numerator, equal to 0. So in this case, I'm actually going to have 2 x-intercepts at 0, 0 and at 1, 0. And for my y-intercepts, I plug in 0 for x. And I'm going to get a 0 in the numerator over -12 in the denominator. So my y-intercept is 0. So 0, 0 is going to, correspond to the x-intercept as well. Vertical asymptotes or holes. How do we determine these again? We go and look at our factored form, and we look to see if any of the factors cancel. Okay. If a factor does not cancel, then that factor gives us the vertical asymptote. So the restricted value is our vertical asymptote. Okay. Since neither one of these canceled, both of them are vertical asymptotes. Horizontal or slant asymptote, we go back to the original, take the term with the highest power in the numerator, the term with the highest power in the denominator, compare those terms. Since they're the same number, they're just going to cancel. And we're going to have a horizontal asymptote when y equals 3. We're going to see if it cancels by setting the simplest form. And I'm going to actually use the original because I know I'm going to have to multiply things out anyway. Equal to 3. Cross multiply 3x squared minus 3x equals 3x squared plus 3x minus 36. My 3x squareds are going to cancel. -6x is equal to -36. So it's going to cross over this horizontal asymptote at x equals 6. And we're just going to put that on hold for a minute. So we're going to identify some of the important things that we need for graphing. Our x-intercepts, our y-intercepts, our vertical asymptotes, our horizontal asymptote, and the fact that it intersects it, okay? Let's put some of this information on our picture. My x-intercept at 0, 0, and I have an x-intercept at 1, 0. My y-intercept is at 0, 0, it's already there. I have a vertical asymptote at x equals -4. I have a vertical asymptote at x equals 3. And remember, my graph can never cross over these. I have a horizontal asymptote when y equals 3. And we just found that our graph can cross over this. X equals -4, x equals 3, y equals 3. And I'm going to cross 1, 2, 3, 4, 5, 6. So my graph's going to cross over there. I'm just going to extend my graph a little further, my line, my asymptote, just to show you. Okay, so now that we have our framework, this is all of our important stuff. We could look at the picture, okay? However, I kind of know. Let's just talk about, we have 3 sections here. 1, 2, 3. I know my graph has to cross through the x and y intercept, so I sort of know my graph has to kind of go like that somehow. Which kind of leads me to believe that my other pieces are going to be up here. Why? Because if these are my x and y intercepts, I can't cross through over here. So, I mean, we can use common sense, or you could pick a point, or if you want to make things quick, you can just kind of look in your calculator. I think I might do that for this one. Because our graphs are going to be, basically, we're going to be checking in our calculator anyway. I just want you learning how to find the important stuff algebraically. X squared plus x minus 12. And if we graph that, and kind of, well, I don't know if I can zoom in anymore, but you basically see we have the horizontal asymptote, right? Let's see if I don't know if you could see it. Okay, you have this was your middle piece here, right there. And then our other 2 pieces are up here. Okay, now, this one though, we have to remember on this side, my graph is gonna cross, and it doesn't keep going back down because I know as x goes to infinity, my y values are gonna hug the asymptote. So I'm gonna go down just a little bit, and then start heading back up. You don't really see that in your picture, but that's really what's going on. And then my other piece is up there. Okay, so that's the actual graph of your curve. And don't stress out too much if you're not getting that crossing over the asymptote piece. I just kind of like to talk about it, but it's not a huge focus. Okay, I'd rather you be able to understand something like this that we did yesterday a lot more. And our last example that we're going to work through together, x squared minus 1 over x. Domain, very easy to see. X can't equal 0. Okay, remember, this breaks up our x-axis into those 2 intervals, right? That's our restricted domain. Factored form, x plus 1, x minus 1 over x. Nothing cancels. That's my lowest form. Again, no big deal. X and y intercepts. X intercepts. Set the numerator of your factor, of your simplest form equal to 0. I'm going to have an x-intercept at -1 and an x-intercept at 1. My y-intercepts, I plug in 0 for x, and since I'm going to get a 0 in the denominator, it's undefined, which means there's no y-intercept. Again, okay. Okay, just take what you find, and we're going to put it together at the end. My vertical asymptote or whole. So I'm going to go back up and I'm going to look at my factored form and see what happens. Okay, nothing cancels. So I have a vertical asymptote, and that is x equals 0. Horizontal or slant asymptote. Now when I go back up to the original and I take out the term with the highest powers, I see that I'm top heavy, okay, by 1 degree, right? Top heavy, 1 degree. So I'm going to use long division to find my slanted asymptote. And that's going to kind of go like a slanted line in my graph. X squared minus 1 divided by x. X goes into x squared, x times x squared. Bring down the 1. X goes into -1, does not. So remember, we stop here. And we take whatever's on the numerator. And that's our slant asymptote. So my slanted asymptote is the line y equals x. Now I have to see if this is going to intersect. So I take the simplest form, and again, I'm going to go back to the original, because when I solve equations, I distribute everything out anyway. Set that equal to x. X squared minus 1 equals x squared. Obviously, if I subtract the x squared, it's just going to disappear, and I get -1 equals 0, and that does not happen. So it does not cross. Now let's put our important information. Highlight it first. X-intercepts. There's no y-intercept. I have a vertical asymptote, and I have a slanted asymptote. All of these pieces have to go onto my graph before I actually draw the physical graph itself. X-intercepts, I need to make this bigger. -1, 0, and 1, 0. No y-intercept. A vertical asymptote at x equals 0. A slanted asymptote, and that's the line y equals x. And remember, the line y equals x is just this diagonal line that runs through. So x equals 0, y equals x. And I don't even have to test numbers here, because if you think about what happens in a rational function, I've got my x-intercepts to help me tell me where the graph is. Okay. My graph has got to be in this section here. It's kind of got to hug the asymptotes, so it can't be down there. It's going to hug the asymptotes. You'll see in some situations your graph is going to be down there, but not in this instance. If you don't trust yourself, plug a point in and see what happens. Or just take a quick peek in your calculator. And you see your picture. want to slide it so it's like that. Your picture in your calculator matches the picture on your graph. Last thing we were working on yesterday was describing our asymptotic behavior and our end behavior. So our asymptotic behavior deals with the vertical asymptote. So I have one asymptote here. So I'm going to talk about what happens as x approaches 0 from the left, what's happening to the graph, and as x approaches 0 from the right, what's happening to the graph. Well, if I go to 0 and I go just to the left of 0, what's happening to the y values? As I get closer to 0, my y values are going to infinity. On the other side of 0, as I plug in x values that are close to 0, my y values are going to negative infinity. And now my end behavior, this one's going to be a little bit confusing at first, but it won't be so bad. Remember, end behavior as x goes to infinity and as x goes to negative infinity. We want to describe what's happening to the y values. Now, in the examples yesterday, since we had a horizontal asymptote, it was a number. But if you look here, as I plug in x values, as x goes to infinity, your y values are just going to continue with that line. So as x goes to infinity, y goes to infinity. And in the other direction, as x goes to negative infinity, my graph is going to follow my line and go to negative infinity. Okay, so use your picture to help you. Okay. Next year, we're going to talk, use other methods, but right now we're using our graph to help us with this new terminology. Oh, and that was it. Okay, so that was what I wanted to talk about today. Thank you, and we'll see you soon.